Excuse me. You're blocking my C. Hey! What are you doing with those beautiful things?
These are not beautiful things. They're mean. They're heartless. They're like my math teachers.
I'm sure that will not solve your math problems.
You're not a math teacher, are you?
No, I'm not, but I love math.
So what are you? Are you one of the geeks in school who loves math?
Let me show you something. Come here.
What's this?
This is the view you were blocking earlier.
This is a seascape?
Yes! You don't sound convinced.
I may not be good at math, but I know how to identify a picture of a sea when I see one. What has this got to do with you loving math?
This is an abstract rendition of the sea. Okay, I bring back the same things I see to its simplest shapes.
Okay.
In short, I am painting the pattern of the seascape we're looking at now. See? Now, there's really one thing in common between the study of art and math. That is the study of patterns. And if you learn to love studying patterns, you'll eventually learn to love math.
You're still a geek to me with an added touch of artsy-fartsy stuff, you know.
Not for long. May I borrow your shells?
My shells. Wait, get one. Here you go.
That's it. By the way, what's your name?
My name is Tim.
I'm Gemma.
Nice to meet you, Gemma.
Nice meeting you too. So, let me show you the figures.
Okay.
How many shells are there in figure 1?
1,
Okay, that's good. What about in figure 2?
4,
What is the shape of the second figure?
looks like the letter Y.
Good! How many shells are shown in figures 3 and 4?
7 and 10.
Correct. And what are their shapes?
Still the letter Y, although this time it's bigger.
Okay, that's good. Now, let's predict how many shells will be needed to make figure 5.
Still the letter Y, but this time it's bigger.
Predict how many shells will be needed to make figure 5.
Let me see. The fifth figure will need 1, 2, 3. 1, 2, 3 more. So, 10 plus 3 is equal to 13.
Correct. What about figure 6?
Figure 6, okay. So, 13 plus 3 is equal to 16.
Will the Y figure be maintained?
Yeah.
Now, Tim, tell me, how many shells will you need to create the Y figure in the 100th sequence?
100th?
Yep.
Hey, Gemma, can I talk to you for a minute?
I'll be there! So, tell me the answer, okay? When I come back.
But that's difficult. I don't have the whole day.
I have faith in you. You can do that.
Oh, man. Gemma! 100.
Hi, Tim. What are you doing?
I'm solving the problem.
Uh-huh.
Did I do something wrong?
No, it's okay.
I told you I'm not really that good in math.
It's really okay. You know, you don't have to go this far. There's nothing wrong with what you did. But, you see, you can use mathematics to help predict the numbers in sequence. Now, can you see a pattern from the sequence of numbers?
When I was arranging the shells, I noticed that the branches move by threes as the sequence progresses.
Right! The number is called common difference. Now, can you see the relationship between the common difference, the figure number, and the number of shells in the figure?
Let me see. If I multiply the common difference, or the number 3, with a figure number, I get these numbers. 3 times 1 is equal to 3. 3 times 2 is equal to 6. 3 times 3 is equal to 9. 3 times 4 is equal to 12. 3 times 5 is equal to 15. 3 times 6 is equal to 18. If I subtract 2 to these numbers, I will get the number of shells in each figure. 3 minus 2 is equal to 1. 6 minus 2 is equal to 4. 9 minus 2 is equal to 7. 12 minus 2 is equal to 10. 15 minus 2 is equal to 13. 18 minus 2 is equal to 16.
Good! Now, let's write that pattern in a mathematical language. To get the number of shells, you first multiply the common difference, or the number 3, with the figure number. We can define that as 3n. Then, you subtract 2 from 3n, or 3n minus 2. Let's use the letter S to represent the number of shells and include the equal sign. We get S is equal to 3n minus 2.
I get it! If I want to know the number of shells needed for the 100th figure, I just have to substitute the 100 in place of n. So, S is equal to 3 multiplied by 100 minus 2 is equal to 298. I will need 298 shells.
Yeah! And you don't have to line up these shells in the entire seashore.
Okay, teach me more. Don't tell me you see patterns in what you cook.
Nope, but my tummy does. Now, let's try something with matches.
Okay.
Here, for every additional triangle, we only need to add 2 sticks after the first 3 sticks. We can say that the number of sticks, let's call the number S, is equal to 3 previous sticks plus the quantity of second sequence minus 1 times the common difference of 2. We then get 3 plus 2 equal 5. Try that for the 4th figure.
For the 4th figure, we can say that S is equal to 3 plus 4 minus 1 multiplied by 2 is equal to 9.
We can now predict the number of sticks needed to make the 10th figure. S is equal to 3 plus 10 minus 1 times 2 is equal to 3 plus 18 is equal to 21. What about for the 100th figure?
The 100th figure is S equal to 3 plus 100 minus 1 multiplied by 2 is equal to 3 plus 198 is equal to 201. We'll need 201 sticks to make the 100th figure.
S is equal to 3 plus n minus 1 times 2 can still be simplified. We can say this formula is also equal to S is equal to 3 plus 2n minus 2, or S is equal to 1 plus 2n. Here, Tim, why don't you try this one?
Okay. After the 4 sticks, we need to add 3 more sticks. So 1, 2, and 3. We can say that the number of sticks S is equal to 4 plus n minus 1 multiplied by 3. And to simplify, S is equal to 4 plus 3n minus 3, or 1 plus 3n.
You're getting the hang of it.
But something's bothering me though. What if the world does not have shells and sticks from which to base these patterns? How can we then find mathematical equations?
Tim, I don't think that's a problem for mathematicians, but I think that's a problem for artists like me.
Thank goodness. Show me how.
Easy for you to say.
What's happening to you?
You know, I can't imagine a world without the beauty of shells.
Cut that out.
I can't. It affects me so much.
Please, will you? Stop it. Here, this is for you, Miss Gemma. This is my favorite shell. I'm giving it to you because you taught me how to love math. And that will also be yours just in case the ocean runs out of shell.
That's sweet of you, Tim. I'm glad you didn't pulverize this one.
Actually, when I saw that particular shell, I thought maybe if there's a shell worth admiring, maybe there's at least one math teacher worth respecting. And I thought maybe that particular math teacher is you.
Thanks, Tim. I'm so flattered. But you know, before we move on to the next method, it's best for us to practice again. That's the only way to perfect math.
Here, we need to add 4 shells after the first shell. We can say that the number of shells, S, is equal to 1 plus n minus 1 multiplied by 4. To simplify, S is equal to 1 plus 4n minus 4, or 4n minus 3.
Try this one.
Here, we need to add 3 more sticks after the first 3 sticks. We can say that the number of sticks, S, is equal to 3n.
Very good. I think you're ready to learn the direct method of equation. You won't need the shells and sticks anymore. It involves getting the differences between consecutive numbers.
What do you mean?
Let's take a look at the sequences of numbers of the 5 samples we solved earlier. Let's call their corresponding equations A, B, C, D, E. The equations in example A to E could have been derived on the basis of the constant differences by extending these to the 0th figure. The 0th figure of example A is minus 2. Using a constant difference of 3, thus we have S is equal to 3n minus 2.
The 0th figure of B is 1 using a constant difference of 2, so S is equal to 2n plus 1. The 0th figure of C is 1 using a constant difference of 3, so S is equal to 3n plus 1. The 0th figure of D is negative 3 using a constant difference of 4, so S is equal to 4n minus 3. The 0th figure of E is 0 using a constant difference of 3, so S is equal to 3n.
In life, we see many patterns. For me, patterns are beautiful. That is why I like to look at nature and discover the patterns and paint them.
I never thought math could be so simple.
Math is simple, and in its simplicity is beauty.
Thanks for sharing the beauty of math with me, Miss Gemma.